Hello, everyone.
Hi.
Welcome to ITS 140. Okay. All right. So I've started grading your exams, and hopefully I will have those done by tomorrow. So just be on the lookout for that. So we are currently on week 7 of the semester, and I'm hoping to have all your stuff graded, by Friday, basically. So hopefully you'll see that. Let's see what else. Next week it's fall break, I believe. So you probably saw that. So no class on Monday. But we will have class on Wednesday. All right, so today we're going to start a new topic, which is called arrays. This is probably one of the bigger topics of the class. As you may have noticed by now, everything that we cover in one chapter kind of is used in the next one. So as you might imagine, the topic that we covered last week, which was loops, and the last couple of weeks, will now be used extensively in arrays, right? But I think you'll find arrays to be very interesting, very powerful. So certainly that should be a lot of fun. All right, so we're gonna get started then with, like I said, today's topic, which is gonna be arrays. Before I begin, are there any questions? All right, it seems like there's no questions, so let's go ahead and get started. Let me go to Brightspace here, so I'm going to share. You should be seeing Brightspace. Go to content. You can see I added the module arrays, which has a couple of, excuse me, several slides. So these are from the old book and the new book, and then this is the PDF for the homework that we will do at some point. And so I'm just going to download both files. All right. So array, I'm going to start with the old book for arrays. I'm going to start with that. And then I'm going to move into the Python book. Given that arrays in Python and in other languages are a little bit different. I mean, they're the same, but they're just a little bit different. So I'm going to start with the general and then kind of move into the more specific. You should be seeing the slides. Oh, wait. Need to switch to that. Now you should be seeing the slides. Okay. All right, so I'm gonna open that up. All right, so we're starting, as you can see here, the topic of arrays. see that here. Arrays, right? So arrays are like variables that can hold more than one value. And the way that we can kind of take all those values as a set of values with one variable name, just the array name, and then from there we can access the values in that set by an index. All right, so by an index. And I think last week I kind of gave an introduction to that. So you've already seen it in Python. And so today I'm just going to elaborate a little bit more. I'm going to elaborate a little bit more on this. Right, so I'm going to mute your microphones. All right. So that's the idea. All right, so the topics in this chapter, as I said, arrays are an extremely important part of programming. You will always use them. So we're going to cover the basics. Okay, we're going to cover the basics. Sequentially searching an array or basically iterating through an array. And then, after iterating through the array, we want to process the contents of the array. We'll talk about what happens when we have two arrays, and if they're the same size, we can treat them in parallel. And then, the very interesting topic of two-dimensional arrays. So what are these? More dimensions to represent our data. And there can be also arrays of 3 or more dimensions, hyperdimensions, or of size n. So we'll talk about that as well. So here's a definition. So an array allows you to store a group of items. So as I said, a set of items, right? A set of values, let's say. Right? So an array allows you to store a group of items of the same data type together in memory. And this actually is not entirely true for Python. As you know, Python is it's not a strongly typed language, and so there you can actually get away with more, a little bit more flexibility, a little bit more overhead too, but so certainly we'll see the differences. But in general, for some programming languages, an array allows you to store a group of items of the same data type together in memory. Okay. Why? Instead of creating multiple similar variables such as employee, 1, 2, 3, and so on, we create an array. And this is very consistent with everything we've been doing all semester, where we started with a whole bunch of statements, sequential statements, and from there we went to modules, right? So we modularized our code. So it's the same idea. It's the same idea there. So it's more efficient to create just one variable and move it around, right? So if you have 50 employees, okay, so declare, string, and then you have employees of size 50. Okay, you can also declare sales amount of size 7. So instead of having 7 variables or 50 variables, you only have one. Now the number in the square brackets that you see there, like the 50 or the 7, is the size of the array, right? You specify. So think of it as I have, all these variables, basically. Okay. So array basics. The storage locations in an array are called elements. Okay. Sometimes they're also called cells. So the little, right? Those are the elements or the cells in the array. Each element of the array has a unique number called a subscript, or I'll call it an index usually, that identifies it. And that subscript always starts at 0. So that's, something you'll have to get used to in programming, that everything begins with a 0 instead of a 1. The reason for that is that, when programming started, you want it to be efficient in the allocation of memory, and you kind of just started at 0, and it just became a convention, basically. So here in figure 8.1, we can see an example of array subscripts. So you can take a look at it. You can take a look at the example. Here we have a constant integer of size 5. That's going to be the size of the array. And then we declare an array called numbers of type integer, which is of size equal size, which is 5. You can see that there. We have the little diagram here that shows that we have a rectangle, I guess. I usually, I like to use the analogy that it's like a train car. So it's like a train car, and hold on, I got some people coming in here. All right, so it's like a train car, and each one of those is, the train, or it's like a train, and each one of those is a train car, right? So you can refer to each train car by the subscript number, and those are the elements, basically. Okay. So some array basics here, you can see in the pseudocode. Assigning values can be done individually using a subscript. So you can see that, we have the array numbers, and then we just reference each index, 0, 1, 2, 3, 4, and then assign values to them, okay? However, as we will see, you won't always, because you want to make code that's dynamic, that is automated. So you will usually use a for loop to iterate through the array. And so that's one of the things that we will kind of explore a little bit more of. That's what's going to make this interesting, is it's much more efficient to use a loop to step through the array. So here we have, for instance, in an example, we have an hours array, and then on index 0, we have the value 40. So that's like a train, where that train car 0 has inside the value 40 or 20 or 1, depending on the index. Now, arrays can be initialized to 0 for specific values, right? So if you want to keep them, arrays can be initialized to 0 or specific values, sorry, not for, to 0 or specific values. So here we have, there are various ways of doing this. This won't really matter in Python, because Python, you don't have to declare the size of the array. You just give it the values. You assign them at the time that you need them. So, but in other languages, C in particular, you'll have to define the size of it. You can initialize things like the way it's being done in that example. Sunday, you have 7 days of the week there. Array bounds checking should be performed to avoid use of invalid subscripts. So that will be a very common error that you're going to make. We all make it, right? Which is when an array has, let's say it goes from 0 to 6, right? Even though the size is 7, but you think, oh no, it goes to 7. So you're going to iterate, 0, 1, 2, 3. When you get to 7, it's going to be out of bounds, what is called out of bounds. So array bounds checking should be performed to avoid use of invalid subscripts. So you're always going to have to kind of figure that out. What I do is what I would recommend is just write the code and then try it, run it. As you'll see me do when we do examples, I'll run it and then I'll get it wrong and then I'll just fix it. And it's kind of how it goes. You definitely, when you're dealing with arrays and you're dealing with bounds and for loops, you have to run it and make sure that it's correct Otherwise, you're going to end up with a common error called off by one. So the off by one error. Believe it or not, errors and input validations are such an important topic that you have an entire course for that. It's called ITS 450. It's software assurance. And basically, that course focuses on quality of software, but also on security as well. So, because obviously, if you think about it, if an array, if you write code and your array goes out of bounds, that's not good, right? Imagine if that was some software in a self-driving car or something like that, and it errors out, you know, it could cause a car accident. And, you know, or it can have other implications related to security, etc. Okay. So for instance, day 7 equals Saturday, you know, as I said, or assign Saturday to day 7 is invalid because there is no 7 index. Remember, even though the size is 7, it actually goes from 0 to 6. So if you think about it, this is 0, 1, 2, 3, 4, 5, 6. No 7. Okay, see that? And so that would be out of bounds. Okay, so you're going to have to watch out for that. Don't worry if that, you know, you make that mistake and you feel, oh man, this is hard. It's okay. You know, everybody makes that mistake, even many years later, right? You'll continue to make that mistake. You'll just get better at it. And as I said, you just have to check. You always have to, you know, debug the code. So it's, remember, it's 20% designing it and 80% debugging it. So, all right. Are there any questions so far? All right, doesn't seem like there's any questions. So as I was saying, so a common error is running a loop one time more. So as I was saying, a common error is running a loop one time more than is necessary, exceeding the bound of the array. All right, so I'm going to mute your microphones. All right, so array basics. So a partially filled array. Sometimes an array is only partially filled. To avoid processing the unfilled elements, you must have an accompanying integer variable that holds the number of items stored in the array. When the array is empty, 0 is stored in this variable. The variable is incremented each time an item is added to the array. The variable's value is used as the array's size when stepping through the array. So that, you know, that's if you're implementing the logic yourself in some languages. In Python, I think I showed you guys last week, you just have to get the length of the array, and that's, you know, pretty much all you have to do. Python is really great, actually, that you can create an array of size 3 and then just append values to it, and you end up with an array of size 5. So it's a variable length array. However, as I said, once you get into languages like C, C++, when you take your C class, you know, you'll have to be more strict about how you define arrays. So certainly dealing with strings and dealing with arrays is one of the more challenging things in C and C++. So basically here in 140, the discussion of arrays, and especially the practice of it with Python, is not at all, it's kind of a light introduction to the topic, I would say. Other languages, even C# and certainly C, C++, they will challenge you a little bit more with that. But, you know, that's the fun of it, right? All right, so we talked about this, and we'll see examples of that. But yeah, logically speaking, you can keep a variable of the size of the array. Any questions so far?
Nope, we're good.
So let's move on to the next slide then. So let's look at this one here. So some array basics. So this is an example, really. As you can see, there's a count variable there. There's an index variable there. So you got the index over here. You have a count. The count variable holds the number of items stored in the array. So logically speaking, right? How many do we have? And then we create a very large array here, size 100. And the array is called values. So here we have our code. You can see there's a loop here. There's another loop here. All right, so we're going to walk through this example kind of to understand what's going on. So first, it's not function calls or anything like that. It's just pretty sequential. So we're going to start at the top. Oops. So we're going to start there. Okay, so we're going to say that display enter a number or -1 to quit, probably. All right, so input the number. All right, so you're going to take number 5, let's say. And then while number is not equal to -1, because that's the stopping criteria, and count is less than size. So count currently is 0 and size is 100. So that's basically just keeping track of how many values we currently have stored in the array. So we have room, right? It's like the train that I was talking about. It has 100 train cars. Currently, all 100 train cars are empty, and you just received the value, number 5, and you're going to store that value in the first train car, basically, the available train car. Although it doesn't have to be the first, I suppose. It could be anyone. So you're going to go in there and you're going to say set values, count. So in this case, count is 0. So you're going to sort of use that as an index in a way. And you assign to the first train car the value number that you just read, which is currently 5. At that point, you set the count. You have a counter here, as I've said, and you increment it by 1. So now you move on to train car number. It would be the second train car, but it's index 1 because the first index was 0. All right. Then after that, you display enter a number again because you're in a loop, or -1 to quit. All right, and you repeat the process. And in this way, you're going to sequentially enter values into the array until you hit -1 or until the array fills up, basically, because you have two stopping criteria, right? You have this stopping criteria and you have that stopping criteria. Any questions about any of that? All right, seems like everything is making sense, hopefully. All right, so now you're going to display. So now you print out, here are the values you entered. So this is going to repeat the process. Now you're going to, kind of enter all the values again. Or sorry, you're going to display all the values again. Right, so this time you don't need to use a while loop. You can just use a regular for loop. So now we're going to use the other variable index for index 0 to count -1. Why count -1? What is count -1, first of all? Well, it's going to be the last number that you entered. So let's say that you entered 17 numbers, right? So it's going to be at 17. But because things go from 0, then the range is going to be 0 to 16. So that's why 17 -1 would be equal to 16. So these are the kind of tricky things that you will have to do with arrays. Okay, so it might be one of the more challenging things to get used to, but it just takes practice, and that's what where a programming language is actually pretty important. you know, if you just look at pseudocode here, you may not grasp this concept so fully. So I do strongly recommend that you take this code and convert it to Python, all right, and try it on your own and understand the differences. It's good sometimes to break things, so just to see how it would break. So, you know, try it without the -1, right? Try it without that, see what happens. It's probably going to give you an error, okay? And then, you know, as you're iterating through this, you're just going to display the values one by one. You're going to iterate from 0 all the way to the end. Okay. All right, so the for each loop, so this is another approach. It's another type of looping. Python doesn't really have anything for that either, but as I said, VB, for instance, VB.NET, languages like that do have it. So some languages provide a for each loop. It works with an array, iterating once for every array element. During each iteration, the loop copies an element's value to a variable. So Python doesn't have that, but that specific thing, I should say, but it does have the, you know, we've talked about it already, for, you know, val in, you know, the list, right? List of items. So it's similar. Python, in fact, can do something like this. Python can do, take it a step further and say for pairs, right? So you could say for, let me make some room here, for key value in list of, you know, elements, let's say. And then list of elements would basically be a list made up of what is called a tuple, right? So we're going to see that today probably. A tuple is now in Python pairs of things. So you can see that here. So I have, let's say, A, B, C, D, E, F, right? So I have now tuples. So when I iterate, I'm going to grab the whole thing, and that's why I can get both parts at the same time, key and value. So we will see that in dictionaries and tuples. That's, so it's actually even more powerful than this. All right. All right, so for each there, you can see that we kind of have the list. So size 5, we have, you know, 5 values, 0, 1, 2, 3, 4, right? And now for each num in numbers, it's the same idea, right? So for each num numbers, these are the numbers, and then we just display them. So as I said, you know, Python does have its own version of that, just not those keywords like that. Okay. Questions about this?
No.
Oh, wow. So all making sense. That's good. All right. Now searching. So as we start getting into arrays, so arrays are really there for us to store data. All right. So that, you know, they're there to store data. So this brings us to the idea of data structures, right? So in this class, you know, you guys will cover a course in data structures later on. Obviously, that's a more advanced topic that requires a whole semester, but arrays are kind of the beginning of that, right? It's kind of the stepping stone into that. So arrays have a lot of data. Imagine that you had an array that had 200 values, or not 200, let's say 1,000 values, and every 10 minutes, you have to search in that array for something. There's some values there. You have to always find it. So if you always have to run that code, that software, you know, every 10 minutes or so, and you always have to search this array, which has even 2,000 values. If you're always just searching from beginning to end, it's going to make your code very slow, right? So this is probably the first time that you've ever thought about that, slow code, right? Because you're searching and you're searching, and it's like you're wasting, right? So imagine you know, when you lose something, right, in your house, right, and what do? You know, you could methodically just start searching every single drawer, every single, you know, nook and cranny in your house, everything, right? And eventually you would find the item you're looking for, but it'll take you a long time. Instead, you're smart and you say, well, I can eliminate these places and I can more efficiently search this way. Maybe I'm going to, you know, and define a strategy, right? So that's the same idea here. So in arrays, you don't always just want to do like a brute force search, okay? But instead, you want to find more advanced, more sophisticated ways of searching that decrease the slowness, right? Or basically speed up your technique, your algorithm. So that's what, you know, that's the topic of searching. Obviously, the first one that we need to learn about is sequential searching, right? Which is going to be the slow one. But just be aware that there's sorting, you know, a lot of sorting techniques of arrays that you will practice later on in your other classes. Maybe even in this one, I might introduce one or two of those. And the idea is, as I said, to efficiently search for things. All right, so let's take a look at simplest version of that, which is a sequential searching an array. So a sequential search algorithm, you can see that here. These are now called algorithms also because, you know, they're just a set of steps now. You know, it's code, but now with a purpose, right? And a specific purpose. And so, you know, like a function, and we're going to refer to it as an algorithm. So a sequential search algorithm is a simple technique for finding an item in a string or a numerical array. And usually it does involve a loop of some kind, right? It's going to involve a loop. All right, so it uses a loop to sequentially step through an array. It compares each element with the value being searched, and as you might imagine, that can get very inefficient if you have a really large array. It stops when the value is found or the end of the array is hit. So those are the three goals of this array here. The three goals. So let's start looking at it. Okay, we have you know, we have basically a Boolean variable that we're going to use to keep track of whether or not we have found our item. So initially it's going to be false. We also have an index, which is initialized to 0. So now we have our loop. While found equal false, right? That's the stopping criteria. So we haven't found it, so it's false. And also we have to make sure that we haven't gone over the bounds of the array. So we can say an index less than or equal to size minus 1. You probably could have also said less than size, right? So there's various ways of solving this. And you know, that kind of thing, just you'll have to get with practice. Okay. So once we've looked at the stopping criteria, while found equal false and index less than or equal to size minus 1, then the next step is to search, right? So we're gonna go in the array. So we have a for loop there. If array index, and remember that index is currently 0, but we're gonna have to increment it. So you're gonna say if array index equal the search value, which is whatever maybe a user provided input or something. So then if there's a match, then you say found, right? So you found the value in the array. You would probably return the index, I would assume. You print out the index. So there's got to be a purpose for this. It's not just about finding it. So you probably say display index. Okay. Else, if it's not found, just increment the counter, right? So you're going to increment, the index here. So you just do index plus 1, and now you have your index there. Okay, and that's actually pretty much it. So as you can see, it's very simple. It involves some kind of a loop, right? So let's see important things. It involves the loop. It involves the stopping criteria, which would be either this one or that one. And then you have an if statement, and you have an increment. So notice how this code actually involves everything we've done so far this semester, except modular approaches, I guess. It's got loops, it's got if statements, it's got arrays, it's got Boolean logic, comparisons, counters. So notice how everything that we've done so far is being used, and we're using those column primitives or what have you, but we're using all these primitives to build far more complex algorithms. Any questions about this one?
So you said index plus 1, so that it'll redo the cycle and expand the search.
Say that again.
So when it says set index equals the index plus 1,
This
you're
one.
plus, yeah,
What about it?
you're adding the plus 1, so it'll repeat the loop, right?
That's right. This is for the purpose of the loop. So notice here what's happening. So let me do this. I'm gonna walk through this one, right? So let's say that we have an array, and the array has, 7, 3, 5, 11, 17. All right, so now the array is, this is the array. Index is currently 0. So we step into the loop, and the search value is 5. So we are looking for 5. So we go in here, and while found equal false, yes, it's false. So false equal, found equal false. So we step in and we say found false is index less than or equal to size is 0, 1, 2. It's going to be 1, 2, 3, 4. It's 5. So 4. And we're going to step through this 0, 1, 2, 3, 4. All right. So then this whole thing evaluates to 4. So then we're going to say, yes, index is less than 4 and found is equal to false. So we go in here. This is currently 0. Array is 0 equal to search value. Search value is this one. Is 7 equal to 5? No. Okay. So we don't do this one, right? And then instead we do this one. So what do we do there? Index is now 1. Okay, now we hit the end while, so we return over here. And now we're going to say, is found equal to false? Yes, it's still false. Okay. Is index less than or equal to 4? Yes, it's 1. Okay, we go in here again. Now array is, what's the value of index here? What's that value currently?
Will be 1.
1. All right, so it's 1. So array 1. Is array 1 equal to 5? No, it's 3 and 5 are not the same. Okay, so we go back, index. Okay, so, we're going to do 2. We go back into the loop, right? And now we say, is found equal false? Yes. Is index less than 4? Yes. Okay, we go into now array 2. Is array 2 equal to search value?
Oh yeah, that'd be 5.
It is, right? Because that's array 2, and search value is 5. So 5 equal 5. So done. So at that point, that condition is true. So now you change found to true. Okay. So that means you don't increment anymore, right? So you go in here and you just say that. When you go back into the while loop, found equal false? No. And so you stop. And that's how it works. Make sense?
Yep, I got it.
Great. Excellent. All right, so let's keep going. All right, so processing the contents of an array. So now the previous one, we were just looking for a match. We were probably just looking for an index. In this one, we're going to try to process the contents. Okay, so we're going to try that. All right, so let's do totaling. Oh, that's a fun one. So we're going to total the values, totaling the values in an array and calculating an average. So now we're getting into useful things because we're doing, statistics, calculating averages, etc. Okay. So loops are used to accumulate values. We have seen that before. And then finally, after that, we simply just take the total that is accumulated and we divide it by the size of the array. So pretty simple, really. It would be something like for I in range size, right? Where size is going to be the length of my array, right? We do that. So this should be length. We've seen that before. We have a variable over here, accum, started at 0. And so we're just going to take then, and we assume array already has values. And then we would do accum plus what? My array with the corresponding index, right? And that's pretty much allows us to collect the data. At the end, we want the average. We just take, we need to do, we already have a cum has the sum, right? And then we just divide that by size. Now here's something important that I would recommend that you always do the math for this. Get a few values, calculate them, all right, and do the average on your own, just to make sure, because maybe size will do that trick where the array is, 7, but it's going to be off by 1, -1. I'm pretty sure it would be size, but I would just recommend you always do the math on this one, okay? Just to make sure, because, remember, garbage in, garbage out, right? So you don't want to just give it, assume it's correct. You want to make sure it's correct. Okay? Any questions? All right, so let's keep going then. All right, so let's now see what the book has here for the average. In pseudocode, I did more of a Python approach. So let's see. Declare a constant for the array size. There we go. So it's size 5. Just going to draw it out. Size. There are 5 elements. It goes from 0 to 4. And it's called scores. All right, so the values are there: 2.5, 8.3, 6.5, 4.0, 5.2. All right, so we have those values there. I'm going to declare and initialize an accumulator variable. You can see that called total. I'm going to declare a variable to hold the average. That's going to be the result. And I need to have an index of some kind. So now I'm going to calculate the total of the array elements. I'm going to calculate the total of the array elements. So for index equals 0 to size minus 1, because it, 0, 1, 2, 3, 4. And I'm just going to take, total, which is 0 initially, numbers. So here, notice there's an error in this example because they called it, this should be scores. See, it's called scores over here. All right, so it's going to be total plus scores index. So you add all those values in the for loop here. And then after that, pretty easily, you just take total divided by size. And you've got your average. So you print it out, and here's the result. Pretty simple, pretty much what I did in the previous example. Okay? Any questions?
So it's adding, when they say set total, what is total? Is total when they added up all the scores?
That's right. So total initially was 0. Total was 0. Let's walk through it. It's a good question. All right, so this time around, I'm going to have index. I'm going to have total. So this should be scores. All right, so what happens? You go into the first index is 0, right? You're going to index 0 to size minus 1, so 4. So it is within the range. You take index is currently 0. So you get this one, 2.5. Total was initialized to 0. Therefore, it has a 0 there. So now you say total equal total plus scores index. So it's going to be here 0 plus 2.5, which means in the first iteration, total becomes 2.5. Okay? Then you finish that. You go back in the loop. Now, what is the value of index? Now, index is 1. Okay? And you say, what is total currently?
2.5.
2.5. And then you go scores 1, right? And so you go into the array. Scores 1 is 8.3. So now you're going to take 2.5 plus 8.3, okay? And you're going to add those together. And so that's going to be, what is that? 10.8, right? 10.8. And you move to the next iteration. So now it's going to be 2. And you're going to say 10.8 plus scores 2. Scores 2 is 6.5. You can see that there. All right, so you're going to take 10.8 plus 6.5. So that's going to be 13, 17.3 or so. And so on. Do you see that? Make sense?
Yeah.
Okay. And that's the approach. That, that's how you iterate through an array. You look at the index, and then until you stop, you would arrive at the total, which would be, whatever at iteration 4, there's going to be a value here. Let's call it x, right? And then you're going to take that x value, divide it by size, and that's going to give you the average, 5.3. Now, I would recommend that you guys, by hand, finish this problem and confirm that you do, in fact, get 5.3. It's not homework, but just on your own, I would do this. I would also recommend that you try to implement this code in Python. in your Jupyter notebooks and, make sure that you understand how it works. Okay. All right, so let's continue then. Please stop me at any time if you have any questions. Otherwise, I'll just keep going. All right, so processing the contents of an array. Now this becomes a little bit more complex now because, it's about finding the highest and the lowest value. So remember what I said, right? So arrays are really like sets of values. Imagine if you have 2,000 values in your array, you might want to, search data. For instance, let's say that, you have an array for the day of total sales, right? You have total sales there. And you want to know for that day, what was my lowest sale? And then what was my highest sale? So every day you just want to report those statistics to see which products are moving, which products aren't, etc. Right? So, you can do all kinds of things like that. And so to do that, right. So, so to do this, then we're gonna, again, as you might imagine, we have an array. We're gonna use some for loops, but now we're gonna have different criteria, right? Because we are not gonna compare the values now. Are they equal? But instead, it's gonna be more about are they less than or greater than, something. And we're gonna have to keep track. Now we have more than one variable involved. So certainly this problem might be a little bit more challenging. But it's like a puzzle, right? It's fun to solve. So let's take a look at the criteria for the highest. Okay, we want the highest number. So let's think of an array actually. And so you have 7, 3, 5, 11, 17, 19, 23. All right, so you have those numbers there. And which one of those is the highest? Which one of these is the highest? You don't know? So 23, right? Obviously. Which one's the lowest?
3.
3, very good. So, you know it because you guys are intelligent. But computers, can't just look at something and understand it. Instead, they have to have, an algorithm, an approach, some kind of technique to figure it out, right? So that's what we're going to teach our computer. We're going to teach it to find lowest and highest values in an array. So the criteria, we need a variable to create. We need to create a variable to hold the highest value, right? So we're going to store that highest value. So basically what this is saying is we're going to start at the beginning, start iterating. We probably just grab the first one because we won't have a value initially. And then every iteration, we have to say, is the current value that I'm looking at greater than the value that I looked at, or greater than the highest value I have in my variable, right? If it's greater, you replace it. If it's not, you just keep going and you look at the next one. So the idea would be, the highest, right? I grab 7. Okay, that's the highest. Then I go to the next iteration. I grab 3. Is 3 greater than 7? No. Okay, don't do anything. Then I go to the next one. I grab 5. Is 5 greater than 7? No. Okay, I go to the next one. Is 11 greater than 7? Yes. Okay, at this point, I need to get rid of 7 and assign 11 to the variable called highest value. Okay, so that's a way of keeping track of the value. You could also just, instead of storing the value itself, just store the index. That's sometimes a little bit more useful because later on, you probably want to know where it was. Okay, so either one, but the problem, so either one would work. You just have to make a decision there. But in this example, you assign the value at element 0 to the highest. That's what I just said, right? So 7. We'll need to write some code to do that. And then we're going to use a loop to step through the rest of the elements. So again, notice, those loops are very handy for just about anything. Each iteration, a comparison is made to the highest variable, okay? If the element is greater than the highest value, that value is then the assigned, or is going to be assigned to the highest variable. Is then probably just then assigned to the highest variable. The lowest is the exact same process, but checks if the element is less than the lowest value. So, whereas before you were doing greater than, in the next one you're doing less than. That's really pretty much the only change there. Okay. Obviously, this logic we are going to have to implement in our code, but it's another example of how arrays store data and then the algorithms that we need to move through them. Okay. All right, so let's keep going. All right, so here we have, so I guess, no example of this, huh? All right, let's just fire up our Jupyter notebook then, and let's do this example, given that there's no pseudocode there. So I'm gonna start my Jupyter. And just remind me, kind of what the goal was. And help me walk through it. All right, so I'm going to share my screen with you guys, and then we'll come back to the slides. So don't worry, I'm not in a rush to get through arrays. I mean, we've covered quite a lot, actually, already. And so, we still have plenty of the semester. So let's see, I need to share Jupyter. All right, so what are we doing? We are finding the highest, and did somebody say something? We are looking at the highest and the lowest, right? Finding highest. I'm just going to say highest. Can you guys see my Jupyter notebook? Yes?
Yeah.
Okay, great. Thank you. All right, so I have highest and lowest there, right? Notice I'm just kind of thinking out loud right now of how to write this code. I need some kind of an array. In Python, we call them lists. There are libraries. There's a library called NumPy. You'll learn. So import NumPy as in P. So within the program of ITS, you guys are in the bachelor's of information technology. Within this, we have several concentrations, and one of them is the data science concentration. So data science is like artificial intelligence, if you ever heard of that. So the focus of our program is not to get you guys to be like, use Excel and analyze things with Excel, that, not enhancing your decision making. That's more of business analytics. But instead, our program is data science, more focused on automation, right? Automation. So as you know, automation is pretty important. It's the whole world is going to get automated if we're not careful, and a lot of jobs are going to be lost, right? So you guys want to be at the cutting edge of not being in careers that are going to get cut off. And so, automation is pretty important, knowing how to do that. And so that's the focus of our program. We have several classes there in machine learning, parallel type of computing. Because what I'm doing here, the programming that I'm doing is not parallel. It's sequential, CPU based. But whenever you want to handle tons of data, I was talking about efficiency before. I mean, the real efficiently with huge amounts of data is done through parallel computing. So that's also one of the topics in the program. As I said, machine learning, data visualization, and what else? Oh, introduction to artificial intelligence, etc. So in there, you'll take some courses like 265 that covers the Python, but a much more advanced Python, getting into parallel type of Python computing. And there you will definitely use a library called NumPy, which now things are going to be arrays again in Python, what are called matrices and vectors. Is a little bit like understanding. It covers a little bit of applied applications of linear algebra in computer math, I guess, but in a very fun way, very applied. All right. Anyway, so that's just kind of me letting you know about that. So that's 265 if you have an interest in it. I believe it's going to be a required course, actually. You guys are freshmen, so it'll probably be required for you, I think. I'm not sure, but it's certainly going to be a required course in the future, so you'll come across that. But anyway, just wanted to say that. If you have any interest in that program, you can shoot me an email, or Professor Jang or Professor Taehoon Kim. We'd be happy to answer any questions. All right, anyway, so let's go. And the reason why I mention it is that, that kind of shows you that getting to arrays in this class starts to get real, right? So you're starting now to be able to do real things. And so, you get to advance to the other classes. All right. Anyway, so let's go back to the code example. So I need an array, right? So I'm going to call it, for now, I'm not going to call anything an array in Python because, you should really use the Python-y language. This is going to be a list, okay? But it behaves pretty much like an array. So I'm going to call it list of values, right? And I'm going to initialize it here. Notice the square brackets, and I'm just going to say same numbers I had. That should be enough, right? So I have a few values there, and so I have that. Now I want to find the lowest and the highest. So I'm just gonna, some kind of a loop is probably in order. So I'm gonna say and I want to have the size. I don't even know the size of that list, right? I just made it up. So I just want size of list, right? And I can create that variable, and then I just do length. So I'm going to do a length of my list, and that should solve everything. All right, so I'm going to say list of values. Okay, list of values. So we have that. And now I can do some kind of a for loop. So I'm going to say for I in range. And I'm going to specify that the range is going to be size. Size of list. Okay. So now here comes the tricky part. The first thing I want to do is I want to look at the value. So I'm going to say, you know, highest and lowest are currently 0, right? So they're definitely for lowest, if all my numbers are positive, I could actually just say -1. And then for my highest, for now, I could just pick a really big number. Let's say 10,000. So I know none of my numbers will be higher than that. So then I can set the ranges. Obviously, there are other ways of solving this that are much more efficient than what I'm doing. But I think for an introduction, this should be pretty simple, or should be a good approach, actually, to get a better understanding of it. So now, all I have to do is I go into my for loop here, and I'm going to say, well, obviously, I need the value in list. So I'm going to take the value list of values, brackets, and I plug in I because that's going to be the index. So this allows me to iterate through all the values in the index. So usually what I'd like to do is I'm just going to do print, and I'm going to take that value, I'm going to call it val, and I'm just going to print it. I just want to make sure that I can iterate through this, right? So I'm going to run it, and there you go. It printed out my numbers in order: 3, 7, 5, 11, 19, 17, 5, 23, 37, 2, 7. All right, now that I have my numbers printed out nicely, I'm going to do something else. So now I need to do the comparison. Go to the kernel. Okay. And now I'm going to need to do the assessment. So I'm going to say if, just going to jump into it and say if val less than what? Less than highest, or no. So I have to think about the logic, right? So I'm trying to find the lowest. So the lowest currently, maybe I have these inverted. I'm starting to think I have these inverted. Let me try it like this. See if that makes more sense. So if val, so I'm trying to assign to highest something, right? I'm trying to assign, so you guys help me out. I'm trying to assign something to highest. Okay. If current val 3 is greater than highest, whatever highest currently is, then assign it to highest. Does that sound about right? So everything at the beginning will be higher than highest because highest is -1, right? So I get 3. Is 3 greater than highest? Sure. So then I assign val to highest. I could also have, to make this even more useful, highest index, right? And then just, you know, -1. And now I can also assign to this not just the value, but the index position. And in this case, what do you think I would assign? You guys tell me, what do I assign there? Come on. The index, right? So I, right?
Wait, I'm still confused. So why is highest -1 and then the lowest is down to 10,000?
Yeah, it's, because I had it flipped, correct? So I think intuitively for you and me, it made sense to write it that way. But actually, now that I'm running through the code in my head, I have to think that, you know, initially the value of highest has to be the lowest because you want it to be replaced right away, right? By anything, even 0 or 1. And so it's going to say if val, which is currently 3, the first cell, is greater than highest, which is -1, okay, yeah. So then replace it. So now highest is 3. The next iteration, which is now 7, it's going to say again, is 7 greater than highest? Well, highest is 3, so replace it. So now highest is 7. The next iteration, you grab 5. Is 5 greater than 7? No, so you don't replace it. Do you see that?
Okay, I got it.
Got it? All right, excellent. All right, so that is highest. But I could probably also do lowest here. So I'm going to just try the same thing, figure out the logic. So again, you know, these are the tricky things. I'm going to take val. It's probably the other way around. Is val less than lowest? Well, lowest initially is we assume that there won't be any numbers that are higher than 1,000. So that's why I picked 10,000. So it's the simplest solution to this one. By no means the only one. So I'm going to say if val less than lowest, okay, then lowest, just like we did before, is equal to val. I also want to have a lowest index. Right, I want to have a lowest index, and I'm going to say, doesn't matter what it is, just -1. I don't have an index -1 in there. So I can assign also here lowest index equal what?
Index, right?
Index, exactly. So I. All right. Now, hopefully that works if I haven't missed anything. So I'm just going to print out the results. Oops. Stay there. I'm going to say print. I'm going to say lowest, or sorry, highest. Highest value is highest. At index position highest index. And then I'm going to say the same for the other one, print lowest value is lowest at index position lowest index. All right, so I'm going to run this code, see if it works. All right, so it did something. So let's see if it's correct. What's the highest value? 37, right? And it's saying here at index position 8. Okay, let's see. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's correct. And then I'm going to look at the other one. It says the lowest value is 2. Okay, that's good. At index position 9. So let's see that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is also correct. Does this make sense, guys?
Yeah, I got it.
Got it? All right, great. Okay, all right, so that's the example that we just looked at. So, nice little fun exercise. All right, we can go back now to this. If there are no additional questions, we can go back to these slides. So let me do a new share. And I think we were here. Yeah. All right, so let's see. We just did highest and lowest. Okay, great. So then we can just continue. All right, so let's go ahead now. Let's see. So processing the contents of an array, now we're gonna, instead of looking for lowest and highest, we're gonna do another exercise. In this case now, we're gonna copy. So this one should be pretty easy. So copying an array can be done using loops, okay? So the idea, I guess, is that we're gonna copy from one array to another array. You can see that here, we're going from first array to second array. Okay, so it's pretty straightforward. We still have an index, starts at 0. And so we go for index 0 to size -1. So then we're going to take the contents of first array into second array. Notice that index will always be the same. We're making an exact copy there. We're basically or I would say we're aligning these arrays. So usually in here, if we were doing a module for an array, we would have to pass the array and the size, although not really. You would do the length of the array. In Python, that's a more efficient way. You actually don't want to hard code that. But here, we will do, as the book says, so we usually must pass the array and the size. The module call, get total, for instance. It takes the array, which is called numbers in this case. You can always just calculate the size. And then we have the module header over here. The definition of it is function integer get total. And then we have integer array, right? And then we have an integer for the array size. All right. So here we have, parallel arrays. Basically, so here these are the same size, first array and second array, addresses and names. So these are for people. So person one. So logically, we're talking about people, person 1, person 2, 3, 4, 5. And then at index 0, we have the first person, we have their name, and then down here we have their address. So whenever we refer to the, index 1, we're referring to a person. All right, so by using the same subscript or index, you can establish a relationship between data stored in 2 or more arrays. As you can see, before we started with variables, then we started with sets of variables called arrays. Now we're starting to talk about parallel arrays. So you can see how we're starting to build even more complex data sets, right? We're building more complex data sets. As I said, in 265, you'll spend some time on building very complex data sets. Also, at the end of this semester, we're going to start object-oriented programming, and that will allow us to abstract these ideas of, we're going to have a data structure called a person, and we can basically refer to one thing, which we're going to call an object, and that object could be made up of many arrays, right, inside. But it's very efficient. All right, but we'll see that in the future. All right, so with the subscript, you can establish a relationship between data stored in 2 or more arrays. Okay. And you can see that here. Notice how this somehow just became a grid, right? Whereas before we just had little arrays, now we have what are called two-dimensional arrays. Two-dimensional arrays. So two-dimensional arrays are used all the time. In fact, you know, every day when you look at your computer, when you look at your TV, you're looking at two-dimensional arrays, right? Because this is, as you know, right? You can draw pictures, right, of things. So grids are actually, you know, how images are made, right? So that's an image. These are pixels, right? And the pixels, obviously you want to make the pixels smaller so that you can catch more resolution. But basically, whenever you're dealing with images, right, you're dealing with grids like this one. If that's grayscale, if you have color images, you're going to have 3 grids of the same size. So it's called RGB, right? Now, if you have video, you have cubes of this, right? Because you have, this is just one image, one image, and you have 24 images per frame, or 20 frames per second, I think. Imagine that. So that's, you know, and all of these things we're doing are the building blocks of our digital society, right? Of entertainment, of TV, and so on. All right, but we have to start somewhere. So we already looked at lists. Now we're going to look at the two-dimensional arrays. As I said, when you guys, so this is, you know, in Python, you can do two-dimensional things too. But really, when you take 265, that will become more, you know, you'll be using a lot more of this idea of arrays. You will kind of, as I said, you'll use NumPy and then, you know, learn about that there. All right, here I'm just going to do a very light introduction to two-dimensional arrays for our course. So two-dimensional arrays, a two-dimensional array is like several identical arrays put together. Okay. Okay. All right, so a two-dimensional array is like several identical arrays put together. You know, suppose a teacher has 6 students who take 5 tests, right? So each of you will take 5 tests, right? So each row here represents a student. So that's student 1, student 2, student 3, all the way to student 6, okay? And then the columns indicate the tests. So this is, you know, exam 1, exam 2, 3, 4, 5. The only thing is they start at 0, right? So there's that offset there. So you can basically then build an array, and this array is, now what's important here is that it has dimensions, right? So the array goes from 0 to 5, and it goes from 0 to 4. All right, so keep that in mind, because now you have, instead of having one index, how many indices do you think you would need here? How many indices? You guys still there? Did you fall asleep?
No, I'm still here.
How many indices? If in a one-dimensional array, we had one index, right? How many indices do you have in a two-dimensional array? How many?
2.
How many?
2.
2, right? 2. So usually by convention, we're going to call this one I and this one J, okay? I and J. So that if I say I equal 2, J equal 3, that means, okay, so I is 2, so that's 0, 1, 2, okay. This row, and then J is 3, so that's going to mean 0, 1, 2, 3. Oh, so this one. Ah, okay, so I found the cell in question is that one. Make sense? Well, that's how what's going to change now. If we need to iterate through all of it, one by one, we're going to need to use now what are called nested loops or 2 for loops. Okay, so you'll see us use that going forward. Okay, so let's keep going. All right, so you can see that there now we have 2-dimensional arrays. We have 2 size variables now are required when declaring this. So we have the number of rows, which is 3, number of columns, which is 4. And then we have the array. So the array is now declared values, rows, and columns, right? And then accessing is done with 2 loops. All right, for both subscripts. So you can have, now you can see we go from 4 rows, row is the index, call is the index. So we go for row equals 0, 2 rows minus 1, all right? And then so that's going to allow us to iterate through the first one, right? So we grab 0, we stay there, but then we go 1, 2, 3, 4, 5. Then we go to the next one, 1, okay, and then again 1, 2, 3, 4, 5, and then again we go to the 2, and then and so on. So we can iterate through each one one at a time. Okay, so here we can write a for loop that goes from 0 to rows minus 1, for columns 0 to columns minus 1, and then you're just going to display something. So maybe we're going to populate the array initially. So we say display of enter a number, and then you're going to input that number into the given cell. So you're going to say values. Oops. You're going to say values. Right, and let's say that you're currently at row 1 in column 2, so then it's going to be 1, 2. Okay, and so therefore there you're going to enter some value. Let's say that the value is 2400. All right, and so that's how that works, right? So that's the idea there. Are there any questions about this? No questions? All right, so let's keep going then. All right, so let's keep going. Now we can take it a step further even by doing arrays of 3 or more dimensions. So now we have even more dimensions, 3 or more. So you can see that here, seats 3, 5, 8. Okay. So now you have a cube, basically like a Rubik's cube. If you want to remember that, how that a Rubik's cube or something, but basically this ends up looking like 3-dimensional cube. And now you're going to index things kind of like into something like that. And so now you have an I, a J, and then you might have a K. All right, so a third index doesn't have to be those letters. These letters are just used by convention sometimes. You can use other letters. Sometimes it makes more sense to say row, column, depth. Whatever you prefer is fine. But you just have a little bit more now, a little bit more information. You can see here they used row, column, and page for that dimension. So they have this dimension, that dimension. Could be X, Y, Z, something like that. So 3-dimensional arrays, you certainly use them in data science, computer graphics, things like that. I doubt that we will use them that much in our course in 140, except maybe to look at one example or two. Logically, you know, that they just would give you more power to store more data, right? So that's ultimately what that would do. Questions so far, guys? Any questions?
So how many index you have is based on how many dimensions?
That's right. That's right. Good question. Yes, exactly. So imagine, now we can't visualize a hypercube, but you could have a cube with 4 dimensions. I mean, mathematically and programmatically, that works fine, right? You can add another one there. And you can keep going. And you can just, you know, it's just more for loops, more indices. You can get to that data. There's no limit to it. I can't draw a picture of it anymore, right? Because we don't have any concept of beyond 3 dimensions, but certainly possible. And programming languages will support it. Any other questions? All right, no questions. Okay, so let's keep going. Oh, and that's all right. So that's the last slide of these slides. All right, so today then we went over, as I said, we went over arrays. So I went over arrays, which is a very important topic, very interesting topic. We went over, you know, just kind of do a summary. I introduced a basic array, basic concepts. We talked about the index and the size of it and the elements. You know, we talked about how to assign values to an array. Then we concluded that it was much more efficient to use a loop, right, and to reference the array by index. So, you know, we started to look at this. We talked about problems like off by 1 errors that, you know, there's really just takes practice to kind of get a feel for these. We talked about partially filled arrays, and when you have these, then you probably want to keep track of how many values you've already added in there. We did an example of how to add values into the array and then how to read the values back. We talked about the for loop, that, you know, that's a built-in thing in Python. You can see that there, just to kind of iterate through a list of items. Then we started talking about searching, efficient searches, and how you can get data. All right, so we did this example of searching for a value, specific value. We talked about totaling, you know, using an accumulator to kind of total the values that we have available and averaging things. You see this example. We went over the example of averaging. Processing the contents of an array. We talked about highest and lowest, and we went over the Python code on how to find the highest and the lowest and the corresponding index for each one. Then we talked about copying an array, right? Copying an array. So we will do more examples of these on Thursday. We'll do more examples of these. We talked, you know, the parallel arrays, basically the idea that you can now have multiple arrays kind of aligned together by index position, and that allows you to store even more data. Then we talked about how we can have actually 2-dimensional arrays. All right, so this takes us to more advanced data structures. All right, we haven't done an example of this yet. Well, you know, we'll do an example if we need to. As I said, this is, you know, you don't really have to worry so much about this for now. We'll just try to master 1-dimensional arrays and then work our way up. This is just an example of how to iterate through a 2-dimensional array. We talked about 3 or more dimensions, kind of just sort of introduce that topic at a very high level. And that's it. All right, so this is a good stopping point for today. And then on what I'm going to plan to do is that on Thursday, I'm going to start with the Python version of the slides, and then we'll just work through some examples. All right, so as I said, be on the lookout for your exam grades by tomorrow. Hopefully I'll be finished. I finished with some of you already, but you know, I can't grade everything at the same time because we're doing everything online, so I have to go one by one. So I'll try to have those by tomorrow. All right, so before we sign off, I'll stay a couple of minutes if there's any questions to answer them. Otherwise, we'll stop here for today, and I will see you guys Thursday.